Hello everyone. Welcome to the solution of LeetCode problem 1123 named lowest common ancestor of deepest levels or deepest leaves. In this problem, according to the problem title, we can conclude that we are given a binary tree and we have to find the lowest common ancestor of the deepest level. So here the root is 3, which has two children, 5 and 1. 5 also has two children, 6 and 2. And 1 has two children, 0 and 8. Now 2 has two children, 7 and 4. So here we can see that 7 and 4 are the deepest level. So the lowest common ancestor of 7 and 4 is 2. So we have to return 2. I hope you understood the problem statement. Now let's move on to the algorithm. Now here in this example, basically we have to find the deepest level's lowest common ancestor. So here let's consider this example. The root is 7, which has two children, which is 5 and 15. 5 also has two children, which is 3 and 6. And 15 also has two children, which is 12 and 16. Now here, these 3, 6, 12 and 16 are the deepest level. So here we have to return the lowest common ancestor of this deepest level. So what is the lowest common ancestor of this deepest level? It is node 7. So basically, we have to implement this algorithm. Now, how can we basically solve it? Now, the basic intuition behind the solution is if in any kind of problem we have to deal with the levels, we will use the breadth first search technique. Here, in the breadth first search, we will search the tree into the level by level order. In the first iteration, we will search in the first level. In the second iteration, we will search in the second level and so on. So here, now to understand the BFS algorithm, let's take a queue. Initially, we have to start the iteration from the root node, which is 7. Now, for the first level, it has only one node, 7. So we have to take the 7. Now, 7 has two children. One is left, another is right, which is 5 and 15. Before that, we have to remove 7 from the queue and we have to insert 5 and 15 to the queue. Now the queue size is 2. That means in the second level, we will find two nodes. So what is the front element? It is 5. Then what is the next element? It is 15. And we have to remove both of them from the queue. Now, after removing, we have to check that 5 also has left and right children and 15 also has left and right children. So we have to add all of them into the queue. So we have to add 3, 6, 12 and 16. Now what is the front element of the queue? It is 3. So we have to remove it and add 3 to a vector. Now what is the front element of the queue? It is 6. So we have to remove it and add it to a vector. Similarly, we have to add 12 and 16 as well, and we will remove both of them. Now, none of the node 3, 6, 12 and 16 has left or right children, so we don't have to add anything into a queue. So our iteration is over. Now our deepest level is 3, 6, 12 and 16. So here we have to find the lowest common ancestor of these nodes. Now, what is the first node here? It is 3. So now let's say 3 is the lowest common ancestor because our node can be a lowest common ancestor to itself. Now 3 is the LCA of 3. So our next node is 6. So what is the LCA of 3 and 6? The LCA of 3 and 6 is 5. Now we have to find the LCA between 5 and 12. So what is the LCA between 5 and 12? It is 7. Now we have to find the LCA between 7 and 16. So what is the LCA between 7 and 16? It is 7. So here we have to return 7, which is the lowest common ancestor of all of the deepest level. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named subtree with all deepest, where a root is given as a parameter. Now here, if the root is null, we have to return null. Otherwise, we have to take the queue which stores the tree node as the value. And initially, we have to insert the root into the queue. And we are initially taking a vector which will store the deepest leaves. Now here, we are running this loop until the queue becomes empty, and in each iteration, we are calculating the label size. Now, we are clearing the deepest leaves, and here we are running this loop until the label size becomes empty, and we are storing the front element of the queue into a node variable, and we are removing it from the queue and inserting the node into the deepest leaves. And here, if node has left children, we are inserting the left children, and if the node has right children, we are inserting the right children. Now, we are initializing the first value of the deepest leaf to its common ancestor value, and here we are running the loop from 1 to the size of the deepest leaves, and common ancestor will be the LCA of root, common ancestor, and deepest leaves of I. And in the LCA, we are taking 3 parameters, root, A, and B as the tree node. And here, if root is null, or root is A, or root is B, we are returning the root. And here, we are running this LCA into the left subtree and into the right subtree and storing the return value into the left and right. And here, if left and right are both exist, we have to simply return root. Otherwise, if the left exists, we have to return left. Otherwise, if the right exists, we have to return right. Finally, we have to return the common ancestor. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.